There are many different types of reactions that we're going to talk about. So this goes back to chapter 8. I believe this is lesson 2 and 3 combined. So we'll start with synthesis. What does it mean to synthesize? So when you're carrying out a synthesis reaction, you're making one single product. So it's usually either elements combined, or you can have two compounds combined and still give you one single compound. So two substances, two or more, generally elements combine and form a compound. And again, so you have one product, but you start with two or more reactants. So two reactants give you one product. Basically, A plus B gives you AB. So if I wanted to react water, I would take hydrogen plus oxygen, and I get water. Water is that one product, so I synthesized water in this case. Same thing with carbon and oxygen to form carbon dioxide. So again, two reactants give me one product. Here's another example. If I had potassium plus chlorine gas, and we know that chlorine gas is diatomic, that's why it's written as Cl2. The product there is KCl. Why is it written as KCl? Because of the charges. Potassium is +1, chloride is -1. So let's predict the products here and write them as balanced equations. Sodium metal reacts with chlorine gas. What's sodium metal? Na. Chlorine gas, diatomic, Cl2. So what do we get? Well, we're going to end up with one product, obviously, because we only have sodium and chlorine to work with, and when they come together, you get sodium chloride. So NaCl, and then you can balance the reaction afterwards. How about if we had magnesium reacting with fluorine gas? Again, fluorine is diatomic, magnesium is your metal there, they combine together, you get an ionic compound, MgF2. Why F2? Because magnesium is 2+. Aluminum reacts with chlorine gas, right? What are we going to end up with when you have aluminum and fluorine? Well, AlF3. Why 3? Because aluminum is +3, and then you can do the balancing. Decomposition reactions are the exact opposite of synthesis. So what does that mean? We take one reactant and break it down into simpler products, which means if I take the sodium chloride I just produced earlier, I can break it apart and get sodium and chlorine out of it. So one reactant breaks down into two or more products. In general, again, you have AB breaking down into A plus B. Example, if you break down water and you do that through what is known as electrolysis, running electric current through it, you're going to end up with hydrogen gas and oxygen gas. Mercury oxide, if it breaks down into what? Well, you got two possible things that makes up mercury oxide, right? Mercury and oxygen. So when it breaks down, it's going to break down into mercury, which is just a metal, and oxygen is a diatomic molecule. So here's mercury oxide. That's what it looks like. When you heat it up, it decomposes, and when it decomposes, you get oxygen gas being released, and oxygen, again, diatomic, and mercury is your pure metal, and mercury is the only metal that's actually liquid at room temperature. There are certain types of compounds that are special when they go through decomposition. So carbonate decomposes into carbon dioxide and metal oxide, and I'll tell you what that is right here. Calcium carbonate, CaCO3. So when you heat up calcium carbonate, the gas that is released is carbon dioxide, and then what's left over is the oxide metal oxide, which is calcium oxide. When a chlorate decomposes, you get the chloride and oxygen. So in a chlorate decomposition, oxygen gas is released. In a carbonate decomposition, carbon dioxide gas is released. That's just something you have to remember in order to be able to do those kind of reactions. So here are some practice ones. If lead oxide decomposes, what do you think you end up with? Pb plus O2. If aluminum nitrate decomposes, what do you end up with? Al plus N2. Again, you can balance afterwards. So, identify the type of reaction. N2 plus O2 gives you nitrogen monoxide, which is NO. And what kind of reaction is that? Well, it's synthesis because you've only made one product. BaCO3 decomposes. What do you think you're going to end up with? Well, first, let's determine if it's synthesis or decomposition. Given that you have one reactant, it's decomposition. So barium oxide, BaO, plus CO2. Cobalt plus sulfur gives me cobalt sulfide. And then we'll look at NH3 and H2CO3 at a later time. And Ni3 decomposes to give me N2 plus I2. For now, that's all we're going to talk about. So you can go to your worksheet that has synthesis decomposition. Go ahead and work on those. And then once you're done with them, you can come back and check your work because I'll solve them for you.